Hello, hello, hello! Glad y'all are here for the help video for quiz 5.17. So in this quiz, we're still talking about quadrilaterals, but we got two additional specific kinds that are going to be added into this quiz. The first one is a rhombus. All right, so remember the way this is set up is all of these four properties are true for every single parallelogram. Ooh, I can barely fit that. All right, and now these are the two properties that are true for rhombus. All four of these are also true, but these are the two specific ones for a rhombus. The diagonals are perpendicular, and the diagonals bisect the angles. So like this angle is congruent to that angle. All right, so those are your special properties of rhombuses. And just so you know, in case I should have gone over this to begin with, but a rhombus is a parallelogram with four congruent sides. All right, and then when we get even more specific, we get into a square. All right. Now, a square is also a parallelogram with four congruent sides, but in addition, it also has four right angles. Okay? So, of course, we have our properties of parallelograms that are true for every parallelogram. These were the two properties that were true for a rhombus. The diagonals are perpendicular and the diagonals bisect the angles. Those are also true for a square. But then even more specifically for a square, the diagonals are congruent. So all of those properties are for a square. Okay, lots of properties, but let's go ahead and jump into this quiz. So it says, Larissa is writing a coordinate proof to show that the diagonals of the square are perpendicular to each other. She starts by assigning the coordinates as given. All right, and it says, since this is a square, the coordinates of h are what? Okay, well, since this is length A, and this one's length A, y'all, this is a square, so all the sides have to be length A, correct? So, since all the sides have the same length, we know that this point goes over A units and up A units. And we only have to fill in the x value, so there we go. And then it says the slope of something is 1. All right. So we're looking for where we have a positive slope of 1 here. Remember, flat lines have 0 slope. Vertical lines are undefined. Uphill is positive and downhill is negative. So the only possible side here that could be a positive 1 slope is KH. So the diagonal KH has a slope of 1. The slope of GJ, so let's check out GJ. I'm going to get a new color. That's this diagonal and it's going downhill. Well, that diagonal is going to be a negative 1. And I guess I should have actually shown you guys the slope formula. Remember, slope is rise over run. So for this black one, we were rising up A units and we were running over A units. So if you rise A over A, anything over itself is just 1. 3 divided by 3 is 1. 7 divided by 7 is 1. Negative 10 divided by negative 10 is 1. So A divided by A is going to be 1. And then if we go back down and we actually find the slope for the red one, we're rising down A units, so negative A, and then over A. And that would reduce to negative 1. Okay, and then the product of the slopes of the diagonal is, well, if you multiply 1 times negative 1, you get negative 1. Therefore, they are perpendicular. Okie dokie. How can this quadrilateral be classified? So, let's start with a parallelogram. The opposite sides are parallel, so ding, ding, ding. A rhombus has to be a parallelogram, but it also has to have 4 congruent sides. And this one does, because we have those 4 tick marks. A quadrilateral is just any 4-sided figure, and that does have 4 sides. A trapezoid is like this, where it has 1 set of parallel sides. So this one is not a trapezoid. Okay. Which statement describes a parallelogram that must be a square? So in order for it to be a square, it has to have all of these properties. The most specific one being this last one. So just because it has some of these properties up here doesn't necessarily mean it's a square. Remember, if it only has the 4 black properties, that's just a parallelogram. And then if it adds on these 2 orange properties, that's still just a rhombus. It has to have all of these, the most specific one being the last one. All right, so let's check our answer options. A parallelogram with a pair of congruent consecutive sides. That means the sides that are next to each other are going to be the same length. So that's good. And then the diagonals are congruent. And that is one of those special ones for a square. So that's actually going to be it. It's going to have congruent sides, and the diagonals are going to be congruent. If you check out the rest of these, a parallelogram with a pair of congruent consecutive sides and diagonals that bisect each other, that's only guaranteed to be a rhombus. That's not guaranteed to be a square. A parallelogram with a right angle and diagonals that are congruent, that could be a rectangle, right? A right angle could be a rectangle. And then a parallelogram with diagonals that bisect each other, well, could be a rhombus. Oh, I'm just putting R's, and I realize that could mean multiple different things. But the only one that works is the first one. Okay, let's check out this one. Quadrilateral ABCD is a square, and the length of BD is 10. What is the length of AE? Well, y'all, we know in a square, check out down here, the diagonals are congruent. Should have highlighted that one, but didn't get around to it. So, because we know the diagonals are congruent, we know that the other diagonal also has to be 10 units. So this whole diagonal here is also 10, but we just want to know AE. Well, because the diagonals bisect each other, back up here to the properties of parallelograms, we know that each of these pieces have to be 5 because it has to cut it in half. So segment AE would be 5 units long. And then the last one, what is the measure of angle SPQ in this rhombus? All right, so I went ahead and pulled the properties of a rhombus. And the cool thing about a rhombus is the diagonals bisect the angles. So if I want to find SPQ, that's my ultimate goal. But I know that SPR, let me color code this. I know that this blue angle here is 2x plus 15. And I know that this red angle, QPR, is 3x minus 5. So because it's a rhombus and because we know that that diagonal is going to bisect the angle, we can set those two pieces equal together. So we can say 3x minus 5 equals 2x plus 15. And then we can solve it. So I'm going to move all my x's over here. So I'm going to get rid of 2x. Since it's positive, I'm going to make it negative. 3x's minus 2x is 1x. I'm just going to bring down the minus 5, and I'm going to bring down the 15. My ultimate goal in solving the equation is to get the x by itself, so now I need to get rid of the minus 5. The opposite of minus is to add. So I'm going to add 5 to each side, because those would cancel, leaving me with 0. Bring the x straight down, and on this side I get 20. So I got x equals 20, but be so careful because the question does not say solve for x. The question says what is the measure of the angle. So you need to figure out the measure of that whole big angle. So I'm going to plug it back into one of these. It doesn't matter which one, they have to be equal. We just set them equal there. So just pick one and plug it in. So I'm going to plug it in right here. I'm going to say 2 times 20 plus 15 would be 55. That's still not your answer though, y'all. That's just the blue angle. The blue angle is 55 degrees, so the red angle is 55 degrees, which means the whole thing, you would add those two up. 55 plus 55 and you would get 110 degrees as the measure of that whole angle. All right, good luck on your quiz. I hope you ace it.